Okay, before I start the video for 4.6, I forgot to give you the work for 4.5. So in 4.5, these are the questions I would expect you to do out of the book. And then this page that I've attached in your sheet is just for extra practice for whenever. So over the summer, whenever you want to do it, whenever you have extra time, this is a really good sheet to practice your derivatives for trig functions. Okay. So in 4.6 we have applications, and the first one says, while out on his trawler, very exciting, John North, a fisherman, notes the height of the tide in the harbor can be found by this, where h is the height of the tide and t is the number of hours after midnight. Okay, and so it says, what's the height of high tide? So when the high is the tide, we could probably use our calculator to find this, and I might do that in a minute, but I just want to talk for a minute about the highest thing, and we have talked about that. So if I look at this, you know, this thing right here, when that's 1, that's the biggest this can be, that height. Okay, the cos of something is never bigger than 1. Oh, that's the sine. The cos is never bigger than 1 or lower than -1. I know 2 cos is bigger, but not this part. So the highest tide can only be 7. 5 plus 2 times 1. So that means cos pi 6t equals 1. Now we got to remember how to solve a trig equation. So I have to say to myself, all right, where is the cosine 1? Well, the cosine is 1 here at 0 and 2 pi and all of these. That's where the cosine is 1. So I know that pi 6t has to be equal to 0, or pi on 6t has to be equal to 2 pi, or however long. Sorry about the bell. So this would mean t is 0, so I'm at high tide right from the start. Okay, and this would mean t equals, now if I take this over there, keep, change, flip, the pi's are going to cross out and I'm going to get 12. And you can see that if you go to here, you're going to get again t equals 24. Okay, so all those times are when the tide is highest. Okay, and it's at 7 meters. That's what it told me there, that the height is in meters. So it's at the start, and this says hours after midnight. So midnight, midday, and then midnight again. And then it says, what's the difference in height between high tide and low tide? We just talked about if cosine is the highest at 1, the lowest it is at -1, which would be 5 minus 2, or 3. So the difference in high and low tide is 7 minus 3, oops, 3, my head got ahead of me there, or 4 meters. Is the difference in high tide and low tide. Okay, I paused for a minute and I made kind of a daggy sketch here, but I put the 24 hours that I needed, and then I put my high tides that I knew were at 0 and 12 and 24, and so I know because of a periodic function the job of graphing. But that's what I'm looking at. And so that's a good enough sketch for just doing a sketch. You could also do it on your calculator. And remember that you need to be in radians. I'm in degrees right now, so remember that you go mode and then down to radians. In fact, all this stuff is always in radians. The derivative is taken in radians. And I could graph y equals, let me clear out this stuff. I could graph y equals 5 plus 2 cos, and then I'm going to do my fraction pi on 6x, and in the brackets. And I would maybe go to my window and say, okay, I know I'm going from 0 to 24, and I know that I have to go all the way up to 7, so I might put 8. Oh, that's the minimum. I'll put the minimum as 0, and I might go up to 8. Okay, and I could graph that, and I could make sure that my graph that I drew, sorry about that light in here, is the same as the graph, the dodgy thing, same as that graph. Okay, so I could look at it and say, okay, good, I've drawn the right thing. And then the next question, I think they say that John North needs to have 6 meters to get in, and they ask about, you know, between what times of day can he get in the harbor. And so that's another equation I have to solve, which is 6 equals 5 plus 2 cos pi on 6t. So 1 equals 2 cos pi on 6t, and so cos pi on 6t equals 1/2. I hope you kind of remember where the cosine is 1/2, because that's where you need to think right here. Where is cos theta equal to 1/2? And that is at pi on 3. So, and I guess also, you know, in both of these places, at pi on 3, and then this is 6 pi on 3, 2 pi, so 1 off, so 5 pi on 3. So that'll help me get started with these first two, and then I can use symmetry to find the other two. So when you set pi 6 on t equal to pi on 3 and do the keep change flip, you get t is 2. Okay, so at 2, that makes sense. In 2 hours I get there. And then when you find this one, and you can even see it from symmetry, pi 6t equals 5 pi on 3, you get t equals 10. So there at 10. And it's easy to see from the symmetry, I would guess, that I'm on either side. So he can go in to the harbor between midnight and 2 a.m. We can go in at 10 a.m. Till, I think this is going to be midnight. Let's see, between 10 a.m. and 2 p.m. That's going to be symmetric. And then he can't go in there. So just between here. Right, from there to 2 out, so that's 22. So between 10 and midnight. So these are the only times when he can get in the harbor, when the water is above that height. Okay, I hope that made sense to you.